Hi, so this is going to be my fifth video for section 5.62 area between the curves. So now at the beginning of this chapter we learn how to find the area under one single curve. So if you have one single curve and if you just want to find the area between that curve and the x-axis, then you just integrate the function from a to b. Okay, just one curve, x-axis, is integrate the function from a to b. But now we are trying to figure out how to find the area between two curves. Alright. So here is one curve, here is two curves, so you want to find the area between them. So likewise, remember what we did for the single curve? We did was we broke the area into small areas. And we use the fact that big problem is equal to the integral of the small problem. And we got the small problem as a little rectangular piece, right? And then we actually calculate the area of the rectangular piece and we integrate that. Now we are going to do the same thing here, except that now we have two curves. So what we do is we break this area between these two curves into these rectangular pieces. Can you see that? And now let's take one of these pieces. So what we do is we can find the area of one of these pieces. Then we can kind of create the sum from that, and that will turn out to be the integral. Very roughly speaking. So how do you find the area of this little piece? Okay, so this piece, if you look at this area, this is a rectangle. So the thickness of the rectangle we always denote by delta x. And the height of this rectangle, so don't worry too much about the k, because usually we select all the deltas to be equal, so you can think of this as delta x. And then if you look at, so the area of the little rectangle would be the length times the height. So length would be what? Delta xk. What would be the height? The height would be, now there are two curves, right? The height will be, so the height of the first curve is f of x. The height of the second curve is g of x. So you subtract the two things, f of x minus g of x, right? That's it is c there, but basically you take the f curve minus g curve, that will give you this height. So the area of the little rectangle which stands between the two curves, it was f minus g times delta x. So because big problem is integral of small problem, big area between the curves is the integral of the small area between the curves. So the small area between the curves is f minus g times delta x, right? Then the big area is the integral of what? F minus g. So this is the formula that we'll be dealing with. Okay, so once again, big area is big problem is the integral of small problem. Big area is the integral of small area of this piece. And this piece area is delta x times f minus g. F minus g times delta x. So let's go straight to an example. So if you go straight to an example, let's take this example. We're going to find the area between two curves. So 2 minus x squared and y minus negative x. So the first thing we should do would be to draw the two curves, right? So what is 2 minus x squared like? Well, it's a parabola. So if you can forget the 2, then what do you have? It's minus x squared, which is what? And if you forget the minus, then you already have. We just have x squared, which is a parabola. So the minus will flip the parabola, flip it, and then because there's a plus 2, you shift it up. So flip parabola, so x squared is something like that. Minus x squared is something like that. So if you flip it up by 2 points, then you get something like that. Can you see the parabola? That's the blue line is a parabola. So what about the line y equals minus 6? We all know that y equals x is a straight line to the origin. So minus x is what? A straight line to the origin with slope minus 1. So slope is minus 1 through the origin. So this is 1 plus 2 minus x squared, and this is minus x. Alright? And now once you draw the diagram, the next thing to do would be, if you are going to use this formula, you need to find these limits, a and b. So what are the limits? So those are the limits of the area bounded by the two curves. So now you look at this area, right? That area is boundary. The boundary of the area are these 2 points. So you need to find these 2 points. So how are you going to find these 2 points? So those are the points at which the two functions intersect. Alright, so if you want to find the point of intersection between these two functions, what you do is you set them equal. So you set 2 minus x squared equals minus x. So that's what they have done. In the book, root 2 minus x squared is the first curve is equal to the minus x. So why are we doing this again? I said in the two functions equal so that you can find the point of intersection between the two curves. But those actually are our boundaries, and the x coordinates will be the limits a and b. Okay, so the two equal. So you set them equal. Okay, so when you set them equal, then 2 minus x squared equals minus x, and then if you take everything onto the right hand side, then the x squared becomes positive, right? And the minus 2 becomes minus 10, so you actually have x squared minus x minus 2 equals 0. Now that can be factored as x plus 1 and x minus 2 equals 0, so you get what? X is either equal to negative 1 or x is equal to 2. So now, negative 1 and 2 are the x coordinate, right, of these where the two curves are equal. In other words, negative 1 and 2 are its coordinates where the two curves intersect. So the two curves intersect, one at negative 1, can you see, at x equals negative 1. Another one is at x equals 2, can you see, x equals 2. So then what do? We integrate from where to where? Negative 2 to 2. We get what? We integrate f minus b. So f is the top curve, g is the bottom curve. So what's the top curve here? Top curve here is the parabola. So that's what? 2 minus x squared. So you integrate f minus g, 2 minus x squared, minus the second curve is the lower curve, which is what? Minus x. So it's minus minus, be very careful, it's subtract minus x. So really it becomes plus x at the end. So when you simplify this up, you get 2 minus x squared plus x. So 2 minus x squared plus 2 minus x squared plus x. And this is a very simple integral to do, right? So we just integrate it from negative 1 to 2. So use the power rule. So the integral of 2 is what? 2x. The integral of x is x squared minus over 2. The integral of x squared is x cubed over 3. And now we put the limits negative 1 to 2. So when you put the limit negative 1 to 2, what do you get? Well, you get what? 2 times 2 is equal to 4. Put top limit 4 plus 4, 2 squared over 2, which is 4 squared. 2 squared is 4, 4 over 2, minus 2 cubed over 3, which is 8 over cube. Subtract. When you put negative 1, you get what? 2 times negative 1, which is negative 2, plus negative 1 squared is positive 1, so positive 1 half. So negative 1 is negative 1/3. So if you now simplify this madness, so you get like 4 plus 2 is what? 6. And then 4 over 2 is 2. So 6 plus 2 is 8. And then you have minus 1/2 from there, which is 8 minus 1/2. And then you have negative 8 minus 1 is negative 9 over 3. So it's 3. So you have what? 6 from here. And then plus 2 is 8. And minus 3, 8 minus 3 is 5. And then we have 5 minus 1/2, which is of course 9 halves. Okay, so that's the answer for that. Let's do another problem, guys. Okay, so the second problem is to find the area between the curves 1 plus x squared and 3 plus x. So once again, the curves of it, step 1 is to sketch the two curves. Here also, step 1 is to sketch the two curves, right? And then step 2 would be to set them equal and find the intersection. So step 1, sketch the two curves. So once again, this is easy to sketch using transformations. X squared is just the parabola, right? And then you add 1 to that, so you shift the parabola by 1. So this curve right here is y x1 plus x squared, the parabola. And what is x plus 3? That's a curve which has the y x intercept equal to what? So the y intercept will be, you put x equals 0, you get what? 3. So how do you draw this straight line? So the easiest way to draw a straight line would be to find the x and y intercept, right? So how do you find the y intercept? You just plug in x equals 0. When x equals 0, you get what? Y equals 3. So that's y equals 3, right? And then if you want to find the x intercept, right, you set this equal to 0, you get x plus 3 equals 0, with x equals minus 3. So the x intercept is minus 3. So minus 3 and 3 are the two intercepts. You join them together, you get a straight line. So these are the two curves, okay? But now we need to find out, we wanted to find the area, so top curve minus bottom curve integral, but you need to know the limits. So what are the limits? Negative 1 and 2. How do you know that? Well, the way to find that is what? Set them equal, right? So like we did before, The next step is to set the two curves equal. Very careful. You got to first draw the two curves and see whether that's what you want to do. So we set these two equal. So then x squared plus 1 is equal to x plus 3, and bring everything over to this side. Then factor with x minus 2 times x plus 1 equals 0, and then you get x equals 2 or x equals negative 1. So now you can find the area. Area is equal to the integral of top curve minus the bottom curve. Right? So what's the top curve? The top curve is here, not the parabola here. Now it's the straight line. Now here the top curve was what? The parabola, because it was like that, and the bottom curve was a straight line. But now things have changed here. Top curve is this. We are looking only at this piece, remember? As far as this piece is concerned, right? The top curve is a straight line, which is x3, x plus 3, and the bottom curve is a parabola, 1 plus x squared. So it's what? So x plus 3 minus quantity x squared plus 1 plus x squared. Remember to put quantity here so that the minus sign gets distributed properly, okay? So now if you to distribute this out, you get what? X plus 3 minus x squared minus 1. So now if you really look at it, you get x minus x squared, 3 minus 1 is what? 2. When you play that, you get what? X squared over 2 minus x cubed over 3 plus 2x. So we are integration from negative 1 to 2. So you put the limits negative 1 to 2. When you put the limit 2, you get what? 2 squared over 2, which is what? 2 squared is 4, 4 over 2 is 2. When you put 2, you get what? 2 cubed is 8. So 8 over 3, negative 8 over 3. When you put 2 here, you get 2 times 2 is 4. So 2 minus 8 over 3 plus 4. Subtract. When you put the value limit, you get what? Negative 1 squared is 1. So 1 half. So negative 1 cubed is negative 1. Negative 1 third minus, right? And then there is a plus there, right? Negative 1 third, and then minus because plus is positive 1 third. So if you put negative 1, you get what? 2 times negative 1 is negative 2, and that's negative 2. You subtract the whole thing, so you get what? So once again, like the previous situation, you get 2 plus 4 is equal to 6, 6 plus 2 is 8, so 8. And you get negative 1 half from here. And then you get negative 8 over 3 minus 1 over 3, which is negative 9 over 3. Negative 9 over 3 is 3, so minus 3. So 8 minus 3 is 5, 5 minus 1 half is 9 over 2. You can say same answer like last time, but that's a coincidence, okay? Alright people, that's it for this flip video, right? And we'll see you guys tomorrow, and also take a look at the flip quiz that you did, okay? Alright, very good, and then so we'll stop right now. So remember the 3 steps. First sketch, and then set these points, find the points of intersection, usually by setting them equal, and then top curve minus bottom curve. Okay. Now we can only do that because the entire area is covered only by the same pair of curves. So the entire area is governed by the same identical pair of curves. But if these curves change, so for example, if we have 2 curves from here to here and a totally different set of curves from the other side, then you need to use 2 integrals. Check that out in the class tomorrow. Okay. All right.